Good evening, ma'am. Myself, Bindu. I am from the CSE section. I am from third year. Today, I want to tell about the robot introduction, robot software, and architectures and applications of the domains of the robots. So we can see about the introductions of the robots now. So introduction of the robots means robots are an interdisciplinary field focused on the designing and constructing and operating the robots. Robots can perform the task traditionally, and then the humans or too dangerous or complex for humans. The robots can done the task very easily, but it is dangerous to the humans because they uh, they they didn't interact easily with the humans, so it is very dangerous to the humans while doing the any task given perform to task. So the evaluation of the robotics has a significant impact industrial such as manufacturing and healthcare and exploration and matter. So it is a robot has impacted for the industrial to do the manufacturing and health. They can do the healthcare and exploration. So we can see the first what is the definition of main definitions of the robot. So we can see here robotics are disciplinary field that deals the design and construct operational and applications of the robots. The robots are programmable missions capable and carrying out a series of actions auto autonomously or semi autonomously. Robotics combines elements of engineering, computer science, engineering, and physics to create any intelligent missions so that can visualize their environment, process information, and interact with the world around them. The robots can interact with the world around them, and the robots are mainly used to design and construct and operation and applications of all robots. It is a programmation language. Robot is a programmation level language. So it will carry the series of actions autonomously and semi-autonomously. So in computer science engineering, it is the very important to know about the robots, how it will work. So you can see about the robots of shape and the future of the robot. So robot is a rapidly evolving field that transforming the way we live and work. And for the advanced industrial applications to personal assistance, robots are becoming an integral part of your world. And in this presentation, we will explore the exacting world of robots, examining the core concepts and the key of architectures and the diverse applications and the domains and shaping of shaping the future. In this slide, we can see about the robot of the shape. So it is a transforming the live work. It will be shows to the how the task will be completed. So from this industrial applications, they use personal assistants. They can use the robots for their personal assistants, and robots becoming integral part to our world. So we can, in this presentation, we can know about the core concepts and the applications of the domains of the future of the robotics. We can see in this slide. So we can see in the figure of the robot how the robot shape will be occurred. So types of robot we can see. Here the here robots can be classified into the industrial, service, mobile, and humanoid robots based on their applications. Depending upon their applications, depending on their of robots, they can classify into they can use as a industrial. They can use their assistants, so they can transform the work the task from one to another. So they can use in that way in industrial. In service means they can serve in you can see in restaurants, some restaurants nowadays, some restaurants starts with a robot. The robot will be serving to the customers. So we can see that type of services it will be occurred. Mobile also humanoid robots. If it is a humanoid robots means it works as a human same it will work as a human. So they based on their applications they can use the robots types of robots they can be used. So industrial robots are used in manufacturing for tasks will be working and assembly. So service robot assistants humans in a task such as cleaning, delivering, and healthcare support. So we can see we now only we discuss about it. So service robots like humans like robots. Humans like robots, such like they can cleaning and delivering and healthcare and the support. Where they're using the robots like that to do the service to the to service to cleaning or any to do any health problems. It will set our time. It will give to the tablets or anything. It will be useful to us. So we can in this slide we can see the types of robots how they it will work. So robotic software architectures means software architectures in robotic provide the frameworks for integrating various robotic functionalities. Commonly, architectures included layered component-based or behavioral-based systems. These architectures facilitate moderatory and scalability and real-time performance in a robotic systems. It will perform in a real-time performance. It will be based on the applications, based on the robotic functionalities, and it will be works on the real time only. So we can see the software three types of architectures. So deliberative architectures, reactive architecture, hybrid architecture. This architectures involves the planning and reasoning and the decision making. It will be work. The robots are used to approach the builds of a model of the world, plan their actions and their executive and those plans. They will execute their plans. In this architecture, they can use to planning and decision making of the robots. And this model in this model will be used to plan the actions. They plan the actions what will be robot will be act. So they plan that and they executed and they also finally they executed their plans. So in reactive architecture we see robots which has reactive architecture responds directly to sensory inputs without executive planning. They react quickly to change their environment. Hybrid architectures, a combination of a deliberative and reactive approaches. Hybrid architecture leverage and the strength of the both to create a more resilient and adapt to robot systems. In this, both the deliberative and the reactive will combine. The hybrid architecture will be work. So we can see the sensors of a prediction. So the robots are really a variety of a sensors of perceive and understand their environment. The commonly sensors included with the cameras and sonar and the infra sonar and infra detectors. Their sensors will allow the robot to see, hear, and feel and their surroundings, enable to navigate, avoid the obstacles, and they interact with the objects with people. In this object they can use the robot can use due to hear and they cannot be used the they can use the obstacles because they can use the cameras and they can use some types of sensors, IDR, cameras, sonar, and the infra sonar and infra detectors. So these types of sensors that will be can use to hear and they feel their surroundings, what will happening. So these types of sensors it will be used. Motion and control the planning of the robots. The motion of the control through the a combination of the hardware of the software architecture such as electrical motor and hydraulic systems or pneumatic portions provide a physical momentum. Motion planning algorithms they determine the optimal sequence of a momentum and of a task, taking into account factors like obstacles, joint limits, and kinematic constraints. Robotic manipulations. Robotic manipulation refers to the ability of a robots interact with the handle objects of in their environment. This requires advanced grips for the force sensors and control algorithms to precisely grasp, lift, and manipulate items. Robotic manipulation is crucially for the tasks like assembly, packing, and material handling. Industrial robots, we can see industrial robots. Now, industrial robots are widely used for manufacturing and automatic repetitive tasks, increase productivity and improve quantity. And the robotics of often programming perform specific actions which have high speed and accuracy. From making this value of a task will welding, painting, and material handling and assembly lines. You can see service robots. The service robots are designed to assign the humans in every task, both domestic and professional settings. Example include robotic vacuum cleaners and lawn mowers and delivery robots. Their robots is used to sensors navigate and navigation capabilities to perform useful functions and enhance our quantity of the life. Healthcare and accessibility of robots. So robots are is making significant strides and healthcare industrial for surgical robots that can add the delicate procedures or rehabilitation robots to help the patients regain mobility. Assistive robots can also provide support and the elderly and in the industrial with disabilities, improving their independence and quality of the life. The futures of the robots as this technology continues advance to possibilities and the process of are endless. From these autonomous vehicles to intelligent personal assistants, robots will play the increasingly important role of our lives. With going research and development, we can expect to see win over innovative and versatile robots applications that will be performed the way of to life. The work will be interacted with the world around us. Applications of domains of robotics. The robotics spans the diverse fields, including manufacturing, healthcare, agriculture, and exploration. In manufacturing, robots automatic assembly lines are to enhance product uh, productivity and quantity. In healthcare, robots assistance with surgery, rehabilitation, and the patient care it will be taken. So we can see about conclusion of the robots. So robots integrate mechanical and electrical and computer science engine to create the intelligent missions. Robotic software architectures will provide the framework for this same sensing, planning, and control. Well-structured architectures ensure modelability, flexibility, and real-time performance. Robots are applied in the multiple domains: industrial, healthcare, agriculture, defense, and space. Robotic improves efficiency, prediction, and safety in various operations. So thank you for giving this opportunity.